The observable universe is 93 billion light years across. Everything we can see, every galaxy, every star, every photon that has had time to reach us since the Big Bang. But that's not the whole universe. That's just our bubble, our cosmic horizon. Beyond that edge, there's more, way more, and we can never see it, not because it's too far away, but because the light from those regions will never reach us. The universe is expanding faster than light can travel across it, which means there are galaxies out there, right now, that are moving away from us so fast that their light is being stretched into oblivion before it gets here. The observable universe is a tiny island in an ocean we can't measure. And what's beyond that horizon might be infinite. It might be different. Or it might just be more of the same, repeating forever. If you're ready to explore what exists beyond the edge of everything we can see, hit that subscribe button. The journey into the unknown starts now. Let's start with what the observable universe actually is. It's not the whole universe. It's the part of the universe from which light has had time to reach us, the cosmic horizon. Think of it like standing in the middle of a flat field on a foggy day. You can see out to a certain distance. Beyond that, the fog blocks your view. But the field doesn't end at the fog. It keeps going. You just can't see it. The universe works the same way, except instead of fog, the limit is time and the speed of light. The universe is 13.8 billion years old. Light travels at 186,000 miles per second. So you'd think the edge of the observable universe would be 13.8 billion light years away. But it's not. It's 46.5 billion light years. Because the universe has been expanding while that light was traveling toward us. Space itself has been stretching. So the objects that emitted the light we see today are now much farther away than they were when the light started its journey. This creates a bubble around us, a sphere 93 billion light years across. That's the observable universe. Everything inside that sphere is, in principle, visible. Everything outside is not. Not because it doesn't exist, but because the light from those regions hasn't had time to reach us yet. And in many cases, it never will. Here's why. The universe isn't just expanding, it's accelerating. Dark energy is pushing space apart faster and faster. At large enough distances, space is expanding faster than the speed of light. Not the objects moving through space, space itself stretching. This doesn't violate relativity because nothing is moving through space faster than light. Space is just getting bigger. And when space expands faster than light can cross it, light gets trapped. It's like running on a treadmill that speeds up faster than you can run. You're moving forward, but you're falling backward relative to the ground. Galaxies beyond a certain distance, about 16 billion light years in our current reference frame, are receding from us faster than light. Their light is still traveling toward us, but space is expanding faster than the light is closing the gap. Those photons will never reach us, ever. The galaxies are moving away into a region of space we will never be able to see. This is called the cosmic event horizon. And it's shrinking, not in physical size, but in terms of how much of the universe remains accessible to us. Every second, galaxies cross that line. They slip beyond the horizon and disappear from our potential view forever. Right now, we can see about 2 trillion galaxies in the observable universe. But the total number of galaxies in the entire universe, including the parts we can't see, could be vastly larger. Maybe 10 trillion, maybe 100 trillion, maybe infinite. We don't know. We can't know because we can't see past the horizon. And we never will. But here's the question that keeps cosmologists awake at night. What's out there, beyond the edge, in the part of the universe we can't observe? Is it the same as what's here? Or is it different? Does the universe go on forever? Or does it have an edge? And if it has an edge, what's beyond that? There are 3 main possibilities for what's outside the observable universe. Each one is supported by different interpretations of the data. Each one has profound implications for what reality actually is. Possibility 1, more of the same. This is the simplest assumption.
The universe beyond our horizon looks basically like the universe inside our horizon. Same laws of physics, same types of galaxies, same distribution of matter, just more of it, stretching out in all directions, maybe forever. This is what most cosmologists think is true, because the observable universe looks pretty uniform. No matter which direction we look, we see roughly the same thing. Galaxies clustered into groups and superclusters, separated by voids, forming a cosmic web. If the universe is the same everywhere, then what's beyond our horizon is just more cosmic web, more galaxies we'll never see, more stars, more planets, more civilizations maybe, all of it beyond our reach, forever. If this is true and the universe is infinite, then something strange happens. Infinity means everything that can happen does happen. Somewhere. The infinite universe contains infinite copies of you, exact duplicates, living identical lives, and also infinite variations, versions of you that made different choices, versions where small details changed, where you wore a different shirt this morning, where you chose a different career, where history went a different direction. This isn't speculation. It's a mathematical consequence of infinity plus finite possibilities. If the universe is infinite, and matter is distributed randomly, then every possible arrangement of atoms repeats, including you. The nearest identical copy of you is about 10 to the power of 10 to the power of 29 meters away. That's a number so large it's meaningless. But it's finite, which means the copy exists somewhere. You just can't ever reach it, or communicate with it, or know it's there. Possibility 2. The universe is finite, but unbounded. This one's harder to visualize. Think of the surface of a sphere. It's finite. You can measure the surface area. But it has no edge. If you walk in a straight line on a sphere, you eventually come back to where you started. You never hit a boundary. The universe might work the same way, but in 3 dimensions instead of 2. Space could curve back on itself. If you traveled far enough in one direction, you'd eventually return to your starting point. The universe would be like the surface of a 4-dimensional sphere, finite in size, but with no edge, no boundary, no outside. This is allowed by general relativity. The shape of space depends on its density. If the universe has exactly the right density, space is flat, infinite. If it has slightly more density, space curves positively and closes on itself, finite. If it has slightly less, space curves negatively and is infinite but saddle-shaped. Measurements of the cosmic microwave background suggest space is flat to within measurement error, which means either the universe is infinite or it's so large that the curvature is too subtle to detect. But we can't rule out a closed universe. If the universe is closed and finite, then beyond our observable horizon is just more universe. And if you could travel far enough, impossibly far, you'd loop back around and see the Milky Way from the other side. Possibility 3. The universe beyond our horizon is different. This is the wild card. What if the laws of physics aren't the same everywhere? What if the constants that govern reality, things like the strength of gravity or the mass of the electron, vary from place to place? This idea comes from theories like eternal inflation and the multiverse. In these models, our observable universe is just one bubble in a vast foam of universes. Each bubble has its own properties, its own physical laws. Some bubbles might have stronger gravity. Stars would form faster, burn out quicker, maybe never allow planets to stabilize. Some might have weaker electromagnetism. Atoms wouldn't hold together. No chemistry, no complexity, no life. We happen to live in a bubble where the constants are just right for stars, planets, and life to exist. Not because we're special, but because we couldn't exist in the other bubbles. This is the anthropic principle. We observe a universe compatible with our existence because if it weren't, we wouldn't be here to observe it. Other bubbles might exist, other universes with different rules, but we can never see them. They're beyond our cosmic horizon, forever separated from us by the expansion of space. Each bubble is its own isolated reality, its own pocket universe. And the space between bubbles is still inflating, creating new bubbles with new random properties. An infinite multiverse of possibilities, most of them sterile, a few, like ours, capable of supporting life. This isn't proven, it's speculative, but it's consistent with what we know about quantum field theory and inflation.
If true, it means the universe beyond our horizon isn't just more of the same. It's fundamentally different. A landscape of universes. And we're stuck in one small corner of it. Here's the frustrating part. We can't know which possibility is true. Not with certainty, because we can't observe beyond the horizon. Science is based on observation, on testing predictions against data. But if something is fundamentally unobservable, how do you test it? How do you distinguish between more of the same and something completely different if you can't see it? Some physicists argue this makes the question unscientific. If you can't test it, it's not physics, it's philosophy. Or worse, metaphysics. Others argue the question is still scientific, because the theories that predict what's beyond the horizon are testable in other ways. Inflation, for example, makes predictions about the cosmic microwave background that we can test, and those predictions have been confirmed. If inflation is right, and it seems to be, then its implications for what's beyond the horizon are part of the package. You don't get to pick and choose which parts of the theory to accept. There are indirect ways to probe the question. If the universe is closed and finite, we might detect patterns in the cosmic microwave background that repeat, like seeing the same constellation twice in different parts of the sky because light took different paths around the curved universe. So far, no such patterns have been found, which means either the universe is flat and infinite, or it's so large that the curvature is undetectable. If the universe beyond our horizon has different physical laws, we might see effects at the boundary, regions where constants seem to shift, or anomalies in the distribution of matter. Again, nothing conclusive has been found. The universe looks uniform as far as we can see, which supports the idea that it's more of the same all the way out. But there's a limit to what we can learn. The cosmic horizon is absolute. No signal from beyond it can ever reach us. Not light, not gravitational waves, not neutrinos, nothing. Because all signals travel at or below the speed of light. And space beyond the horizon is expanding faster than that. The horizon is a one-way membrane. Information can't cross it. We're sealed inside our bubble. Forever. This creates a strange situation. The universe we can observe is just a tiny fraction of the total universe, maybe an infinitesimal fraction. And we're basing all our theories of cosmology on that tiny sample. It's like trying to understand an entire ocean by studying a single drop of water. The drop might be representative, or it might not. If the ocean has currents, temperature gradients, salt concentrations that vary, the drop won't tell you. We assume the universe is homogeneous, the same everywhere. But that's an assumption, not a proven fact, and we can never prove it, because we can't see everywhere. Some cosmologists find this unsettling. The idea that there are things in the universe we can never know, questions we can never answer. It violates the spirit of science, the belief that with enough time and effort, we can understand everything. But the universe doesn't care about our beliefs. It is what it is. And part of what it is includes regions forever beyond our reach. So what does this mean? That there's an entire universe, maybe an infinite universe, that we can never explore or understand? What are the implications? First, it means we're more isolated than we thought. Not just alone in the sense that we haven't found aliens yet, but fundamentally, cosmically alone, cut off from vast regions of reality by the structure of space-time itself. If there are other civilizations out there beyond our cosmic horizon, we will never meet them. We will never even know they exist. They're in a separate bubble of causality. Their history, their rise, their fall, none of it affects us. We're on separate islands in an ocean of expanding space, forever drifting apart. Second, it means the universe is probably much larger than we can comprehend. The observable universe contains 2 trillion galaxies. If that's just a small fraction of the total, the numbers become absurd. 10 trillion galaxies, 100 trillion, a trillion trillion.
or infinite. Numbers so large they lose meaning. Each galaxy with hundreds of billions of stars. Each star with the potential for planets. Each planet with the potential for life. The sheer scale makes Earth seem even smaller, even less significant. A single planet orbiting one star in one galaxy in one tiny corner of an unimaginably vast cosmos. Third, it raises questions about the nature of reality. If there are parts of the universe we can never observe, in what sense do they exist? This sounds like philosophy, but it has scientific implications. In quantum mechanics, unobserved things exist in superposition, multiple states at once. Observation collapses the superposition, fixes reality. But if parts of the universe are fundamentally unobservable, are they real? Do they have definite properties, or are they in some quantum limbo? Most physicists say they're real, that observation by humans isn't special. The universe existed before we did. It will exist after we're gone. Our inability to see something doesn't make it less real. But the question nags. Reality is what we can measure, what we can interact with. And if something is forever beyond interaction, in what sense does it participate in our reality? Fourth, it changes how we think about the future. Humanity dreams of exploring the cosmos, spreading to the stars, building a galactic civilization, maybe even an intergalactic one. But the cosmic horizon sets a hard limit. We can visit, in principle, any galaxy currently inside our observable universe. It would take millions of years, but it's not forbidden by physics. However, galaxies beyond the horizon are lost to us. Not just difficult to reach, impossible. The expansion of space guarantees we will never touch them, never send a probe, never receive a signal. They might as well not exist. From our perspective, they don't. This means the ultimate future of any civilization, no matter how advanced, is isolation. You can grow, spread across galaxies, build structures on cosmic scales, but you can never escape your horizon. You can never reach beyond the bubble. And over time, as dark energy accelerates expansion, the bubble shrinks. Galaxies that are currently inside our horizon will slip outside. The universe we can see gets smaller, lonelier. Eventually, in trillions of years, our galaxy cluster will be alone. Every other galaxy will have receded beyond the horizon. Future astronomers will look up and see almost nothing. A few nearby galaxies, and beyond that, darkness. They won't even know there was ever a larger universe. The evidence will be gone, stretched away by expansion. They'll be trapped in a cosmic dark age, unable to learn what we know, because the light we see will no longer reach them. This is the ultimate fate, not of matter, but of information. The universe becomes divided into causally disconnected regions, each region isolated, unable to communicate, unable to share information. Stars still burn. Galaxies still exist, but they exist in separate pockets of reality that can never touch. It's like the universe is fragmenting, breaking into pieces that drift apart, forever. What's outside the observable universe? We don't know. We can't know. The cosmic horizon blocks our view, forever. Beyond that edge might be more of the same. Infinite galaxies, infinite stars, infinite copies of you. Or the universe might be finite and closed, curving back on itself. Or it might be a multiverse, bubbles of reality with different laws, each one isolated, each one its own universe. We're sealed in our bubble, a tiny island in an ocean we can't measure. The observable universe is all we get. 93 billion light-years across. 2 trillion galaxies. Everything we can ever hope to see. And beyond that, mystery. Not the kind we might solve someday. The kind that's fundamentally unknowable. Built into the structure of space-time itself. If this video made you feel small, or curious, or both, hit that like button and subscribe to Space and Scale. Next time, we're exploring whether time actually exists, And the answer will break your brain. See you there.